Originally, we were a startup from Belgium. Was called Soft Kinetic. It was acquired by Sony in 2015, then established as Sony Depthsensing Solutions in 2017. And since 2015, we are part of the big Sony group, more specific from Sony Semiconductors, as we are working a lot with sensors, sensor hardware, sensor software. We have the development of the iTOF sensor in Brussels, and as well the software. So the according software, which is very closely developed together with the sensor, is what we are doing. We see advantages combining hardware and software development to get the most efficient product. And we have a high focus on the in-cabin safety. Originally, we come from the comfort features, as since 2015 our technology is used for comfort, for the gesture control, for HMI interaction in automotive series production. But for a few years now we changed, or not changed, but added additionally this safety topic. As we see, automotive safety is getting more and more important. Many companies have this vision, also Euro NCAP, the regulations have the vision of getting vehicles more safer. That's why we see that our technology can really support this. Our technology is this so-called iTOF sensor, indirect time of flight sensor. It's a 3D sensor where you have the advantages of having two outputs of one single sensor. Means that we have a standard 2D image out of the sensor, but on top a 3D image as well. And this 3D image enables to measure the in-cabin very accurate, so we can really see the distances in the in-cabin. How far is the driver seated away from the airbag? Where is he located? Is he out of position, in position? And that's why we are here today presenting our in-cabin solutions to follow, enable the regulations and provide this additional safety. As said, it's a direct sensor. It's a camera-based sensor. It's a visual sensor. We have these two outputs. Standard output, similar like any DMS sensor or OMS sensor. So a 2D image, and on top the depth image. So the depth image means that for each pixel from the sensor, we have the accurate distance from this occupant or from the seat or from any object in the car towards the sensor. With this distance, we can then recreate in 3D the whole in-cabin and then measure all the distances. And with this measurement, enable this several safety features, starting from being out of position, in position, being close to the airbag, which will enable to support active airbags, also future restraint systems, active restraint systems, but as well we can cover the more active safety topics like driver monitoring up to a certain level, activity detection, what is happening on the in-cabin, is the driver drinking, using his phone, is a child in the car, is a child seat in the car. Also, we can cover seatbelt usage detection. So from the camera-based system, detect is the seatbelt buckled in, but not only is it buckled, also misuse cases. So if it's buckled and the seatbelt is behind the back of the driver, also this can be detected with this one single sensor. So we cover actually a lot of the active safety topics, plus the clear advantage from the passive safety topics due to this direct measurement of the occupant size, occupant volume, to adapt restraint systems, to adapt airbag systems, and there we see the clear advantage from our 3D technology. Having one single sensor, having two outputs to provide this input then for the tier one or the OEM to adapt their strategy for in-cabin deployment or intervention of the car in general. We see a huge change at this moment ongoing, coming from the more DMS sensor, which is in the instrument cluster, for example, mounted, and focusing only on the driver and the driver face, to a more full in-cabin approach. So covering all the passengers and adding this additional in-cabin context understanding to improve the safety of the vehicle. So coming from the more driver-focused orientation, where you can detect, is the driver drowsy, is he distracted, which is really only focusing on the driver. We want to enable them to cover all these additional safety topics, like this out-of-position airbag deployment features for the full in-cabin, to give all occupants the same safety standard and improve the general safety with the car. And we see this shift, to come back to your question, happening over the next years, also due to regulations, optimization of the regulations, like regulations getting more stricter, seeing this need for a safe in-cabin and focusing on the full in-cabin as well. That's happening, this is reflected in the regulations, and that's also where the path is going. Full in-cabin monitoring, having several sensors in the in-cabin, having the DMS sensor, having OMS sensor, maybe even have a radar sensor, or on long term also thermal sensors or any other sensor modality to really have this holistic view on the in-cabin. So we see in the UN ECE regulations that the body posture is necessary from 2026 onwards. As well, we see on the NCAP Vision 2030 that in 2026 as well, the first need is there to have the advanced occupant monitoring, including the body posture. That will be even extended further in 2029, when also the whiplash protection will be necessary, or this whiplash protection support from the system to detect also the occupant posture. And with this information necessary over the next years from 2026 onwards is exactly what we enable with our solution, because we measure with this 3D information the posture of each occupant accurately, and then can provide this information to the system and enable to fulfill the future regulations and NCAP requirements. We have the knowledge on the full in-cabin system, starting from the hardware over the software. So that is one of our main advantages, that we really have this 3D sensor available, which is already an interesting technology itself. We see not so many companies working in this field, so that already sets us apart. We have a few competitors, but I think our main advantage is that we, besides the hardware, as well work on the software. So it's all Sony in-house development, and we can optimize the software really according to the sensor hardware, and then provide one full solution which brings the optimum result for enabling the safety for the in-cabin.